I built a web app and integrated an OpenAI assistant into it. This assistant has a summary of all of my YouTube videos and can answer questions based on it. I also used function calling to let the assistant directly interact with the app. In this video, I show you how all of this works so you can build it too. On the KeyCodeGPT website, you are greeted with a little message by the assistant. Hello coder, I'm KeyCodeGPT, an assistant with knowledge about the YouTube channel KeyCodes. We can enter a question like, does Key have videos about Git hooks? It starts querying the Assistant API, and shortly we will see the answer. We see two videos are embedded directly into the chat feed, and the answer is indeed, Key has created videos discussing Git hooks. Here are two videos that might be of interest to you. And now I can just click one of the videos. Let's add a type checker to our commit hook to make and watch it directly in the chat. This system consists of three components. Of course, we have the OpenAI Assistant and the app itself. I also used a FastAPI server to establish the communication between the app and the OpenAI Assistants API. I put the server in the middle for two reasons. First, the server holds the OpenAI API key, which should not be visible inside the app, so nobody can grab it. And I also wanted to adapt the OpenAI Assistants API output to the needs of the web app. The API puts out a lot of stuff we don't need, and I wanted to keep communication small and simple. I used React to build the app, but you can use whatever you like. Everything I show you applies directly to every other web framework. And you are not limited to the web. You could also integrate this into a mobile app, for instance. Before we dive into the code a little, I think it is useful to have an understanding of the API we are working with. The OpenAI Assistants API consists of four different entities. Of course, there is the assistant itself. This is basically the model with the system prompt, the files, functions, and some settings. Then there are threads. Threads are chats with your assistant. They consist of messages which are added by the user or by the assistant. And last but not least, there are runs. After you have appended all the messages to the thread, you can start a run. This queries the assistant to generate an answer to the current thread. Runs are very powerful. They will inform you about the current status of your query to the model. When the app is started, a new thread is created. To get the greeting message from the model, I add this message on behalf of the user. Greet the user and tell it about yourself and ask it what it is looking for. The thread is run. And while the thread is running, the web app queries the API repeatedly until the run is completed. After that, the app fetches the new thread and shows it to the user. When the user now asks something and the assistant wants to embed some videos in return, it can call a function. When this happens, the run status changes to requires action. This tells our system that it is time to do something. You can use this to query other data sources like databases or another API. But in this toy example, we embed the mentioned YouTube videos directly into the chat. Our app now needs to provide the result of all function calls to the run. This triggers the run to continue, and the app waits again for it to finish, and then it fetches the thread, which is then shown to the user. This is the OpenAI playground, and I have assistants selected, and the system prompt for this assistant that is running behind the web app is you are KeyCodeGPT, an assistant with the knowledge about the YouTube channel KeyCodes. I also provided some rules, some files, and a little bit of process for it to work with. If you want to see how all of this is created and what my thoughts are on every line in this system prompt, I link a video up here and in the description below. But there's one rule I added, and that's rule number 5. Trigger video embedding with the function embed YouTube video, but never print the function name in your answer. So this is there so that the assistant knows that it has a function in order to embed videos directly into the chat stream. And this function needs to be defined here as well. And this is done via a JSON. So we give this a name, embed YouTube video. This is the name that we also mentioned inside of the system prompt. We give it a description so the model knows what the function is about. embeds a YouTube video into the chat for the user to easily watch. And then we tell it what parameters it should provide to the function. And in this case, it's just one parameter. It's the URL, which is a string, and it should contain the URL of the YouTube video. To have the knowledge about my YouTube channel, I also provided a file here, keycodesummary.txt. In this file, there is a segment for each of my videos, and each of these segments contain a video title, the video URL, and a 2 to 3 sentence long summary for the model to work with. So how do we put everything together? The first thing I want to show you is the FastAPI server, which I put between the web app and the OpenAI Assistants API. It provides a couple of endpoints to the web app. For instance, /API new creates a new thread and sends the initial message, greet the user and tell it about yourself, to the OpenAI Assistants API. Then it has an endpoint to query the current run status, which simply calls the OpenAI API and then reformats the output. In there we have the run ID, the thread ID, and the status. And if the status requires action, we also get some more information on the action that we need to do in order for the run to continue. And then there is an endpoint to submit the answers for the function calls the model wants to have, an endpoint to get a thread, which we return in our own thread message list data structure, and last but not least, an endpoint to add a new message to the thread. I will not go through every line of code here, but the code is on GitHub and you find the link to the repository in the description below. So now I want to give you a short overview of the React app and how I integrated the React pattern with the OpenAI API. Basically, this is the app, and I didn't do a lot of structuring here. I just structured out the components and the hooks. So what we have is basically one div container which contains the header, the chat messages, and the chat input field. And inside of the chat container there's a message list which is created up here, and we simply get the messages, filter them a little bit, and then decide if it's a video embedding or a chat message and use the right component accordingly. I also added a api.js file in the services folder here, which simply implements the REST calls to each of the different endpoints of the FastAPI REST server that we just saw. And then there are also some hooks that I use for the effects to take place. The first hook I want to go through with you is the use thread hook. It has basically 3 responsibilities, and the first one is to resume or create a new thread. If we don't have a thread ID yet, we either take the thread ID from the local storage or we create a new one. The second responsibility of this hook is to update the thread whenever a run finishes. So we are depending on run, and if it is in a finished state, we simply call fetch thread and set the new thread data to work with. When the thread data is updated, there's another effect that takes the messages from the thread data and some action messages, I show you later, and put this together, sorted into the messages state. Then there is the use run polling hook, which is used to repeatedly call the OpenAI Assistants API when a certain run is not yet in a finished state. You see, we have this start polling method, which repeatedly calls itself, and every time it is called, it just calls the OpenAI API through our FastAPI server, of course, and sets the run data if something has changed, which will then trigger the other hooks that we just saw. Then there is this special hook here, use run required actions processing. And this basically listens for a run to change. And if the run is in the status requires action, we look if the run contains an action with a function name embed YouTube video. And if so, we acknowledge that we have executed the function, and then we add a action message to the action message state. If you remember, we use this to combine with the messages from the thread to get our messages in the chat window. And this is actually the mechanism that is embedding the YouTube videos into the chat. To show you how all of this works under the hood, let's just interact with our FastAPI server and create a new thread. As you can see, we get a run ID, a thread ID, a status which is queued, and no required actions and no error. So our thread was created and a run was queued to actually get the first message from the model. Now we can use the run status endpoint and see that our run is now completed. The next step of the web app is to retrieve the thread. So let's do that. I click here and I get the messages. So first we have the hidden message, which I send when the web app is started or a new thread is created. Greet the user and tell it about yourself. And here we have the answer. Hello there, Coder, I'm KeyCodesGPT. This is then transformed into the little chat messages and shown to the user. Now we add a reply. Does Key have a video with Philips Hue? We see another run is started. The status is queued. I query the status again. This time the output is a lot longer. And we see it has the status requires action. And what we now have is this required action object here, which tells us that the function embed YouTube video was called with the parameter URL. So this is then passed by the web app and used for video embedding as shown before. So the next step to get the run running again is to actually acknowledge that we have executed this function call. For that we take the call ID here and send the call ID together with the output. In our case it's just success true, and run it. So now we see the run status is queued again. I get the run status and see it's in progress and it has completed. Retrieve thread and we see our message. Does Key have a video with Philips Hue? And then the answer, yes, Coder, Key has a video where he demonstrates how to write a commit hook in Python that validates and so on. So this is all there is to it. If you want to see how the assistant behind this web app is created and how you can use the Assistants API with your files, watch this video next. Like the video if you got some value out of it and subscribe to the channel. Have a lot of fun, coders!